All right, it looks like we have a good group. So Armando, if you wouldn't mind hitting the record button, we can get this started.
Absolutely. Oh, it's been recording. Yeah, it's recording.
Perfect. Well, hello everyone. On behalf of TEKsystems, AWS, and Red Hat, I would like to thank you all for joining us and attending today's virtual panel with IDC titled Container Strategy for Modern Hybrid Cloud Environments. Before we get started, I wanted to share some quick housekeeping items. We will be doing Q&A at the end of the presentation, so be sure to drop in any questions you have in the Q&A box throughout the session today. And also be aware that this event is being recorded and will be made available with the deck following today's event. So with that, I would like to hand it over to our presenters to do introductions before we start. Thank you.
Yeah, hi, I'm Gary Chen from IDC. I'm a research director and I cover software-defined compute. So I cover virtualization, cloud system software, and containers.
Hi there, Armando Franco. I'm a lead practice architect with TEKsystems Global Services. I specialize in modern container strategies for hybrid and cloud implementations.
And then I'm Ryan. I'm a partner solutions architect with Amazon Web Services. My focus is on application platforms and modernization practices and hybrid solutions.
All right, so Ryan and I are going to kick it off. We're going to go through some IDC research on containers and specifically a study that we did on the business value of OpenShift on AWS. Next slide. So just starting off, Docker and Kubernetes and containers, that's something that's, really started to become popular. And this slide kind of shows, kind of where we are, right? I mean, there's a lot of hype behind it. Not that that hype isn't, justified. But here we look at, worldwide compute in the enterprise. When you look at what's deployed in a container versus what's deployed in a VM or on bare metal. And containers can run on a bare metal or in VM, so this is not kind of that distinction, but where the app is the primary container for the app is the container. So today we're at just under 10%. We're about 7-8%, of worldwide compute, and it's growing really fast. So it's going to triple by 2024. And containers are a fairly long journey for most. Obviously there's a lot of very cutting edge stuff that starts off in containers, but compared to virtualization, which is the rise of what I covered, that was something that was much more backwards compatible. You could just start going and start virtualizing one thing after the other. In containers, you could definitely containerize existing things, but it's not quite compatible. So it's a different kind of curve. And Ryan, so this is kind of looking at worldwide overall compute across cloud and on-prem. At AWS, you probably see a sort of a different slice of this being kind of more on the modern side, on just the public cloud side. I assume you're seeing a lot of growth as well.
Seeing growth, but I think what's important to call out here is this is a very thin sliver of the customer base. This is the enterprise customers, and they have a tremendous legacy technical debt footprint. They have massive empires that have been built on typically virtualization over the last 2-3 decades. And we're starting to see those organizations self-cannibalize and refactor those technical debt footprints into a different strategy, containers being a very significant one of them. And I think that number that we have here in 2024 is conservative. I think based on conversations that we're seeing, I think we're going to see a lot more of that.
Yep. And yeah, we're going to talk a lot more about modernization and refactoring further on. I have some data on that. Next slide. So looking at just kind of what are the drivers, like what made people start to be interested in containers and Kubernetes. And one, you had to take into account that this data was from infrastructure and ops, right? So this is not necessarily capturing developer concerns, which could be different. But when we looked at I&O people, security was the top concern, actually improving security. And I thought that was pretty interesting. And so, kind of dived a little deeper. I'm like, well, what is it about containers that you think helps you improve security? And we got a number of different things. It's mostly about how they can get kind of a catalog of what's deployed and how fast can they update it, right? So you got a registry, tells you what's in the container, what's deployed, what the version is. You have a CI/CD pipeline. If something needs to be updated or patched, that can happen a lot faster. So that was one part of it. The other part was kind of this whole concept of mutable infrastructure with containers. So that can help solve a lot of config issues, drift issues, which has kind of been a perpetual problem for IT. Some of the maybe the less obvious things that we also heard was kind of just this idea of workload security isolation. So people are used to using VMs for that, and containers are kind of like another layer. So typically containers are deployed on VMs. So you kind of got two layers of isolation. You break out of the container, then you got to break out of a VM. So that can help things as well. And the other part of it was, as people start, decomposing monoliths into microservices, a lot of them felt that, from a security person point of view, that would be easier, because instead of trying to defend one giant piece of code, you split it up and have different postures, right, for different microservices. And then the other things, that were big drivers, which I think, we've all seen a lot of these modern applications, these cloud native apps, particularly on the big data, machine learning, AI side are really popular. Those have been a really good fit for containers. I think Edge and IoT, we've seen kind of start bubbling up, each year higher and higher. And then a lot of it is just kind of, the sort of normal things that have been problems with infrastructure. So, making developers more productive and spending less time tinkering with infrastructure, and just reliability, availability, scalability, and being able to just migrate apps to the cloud, preparing them for cloud. So those I think those are things that we've been seeing for a while. And Ryan, I don't know, what are you seeing from AWS customers? Similar.
If you look at these top sort of line items that we've drawn a block around, I don't see any particular one of them. I see customers very much looking at the aggregate of them. What is a common theme is the drive to get agility within my business, and combining that from a developer practice with the operational or the infrastructure side. So how does cloud and something like a container orchestration platform, this data was largely based around sort of Red Hat OpenShift, how do those complement each other? And you can definitely see it coming through in a portability perspective. How do I migrate to the cloud? How do I manage things that are running on premises as well as in the cloud in that hybrid context? And when we get to the TEKsystems discussion, we're going to dig into this a little bit more deeply, but definitely those are some of those overarching themes that are coming through here. Another thing to note very quickly is aside from security, which is really day zero, or like the most critical thing that everybody's looking at, a lot of these drivers are neck and neck with each other. It really depends on what the customer's trying to achieve and what's important to them. So there's a bit of nuance happening here.
Yeah. And actually, we'll take a look at the flip side on this, Armando, next slide. So on the challenges, so what are the top challenges when you deploy containers? Interesting, security was also a number one for driver, but it was also a number one challenge. And so I think a lot of that is just because that, Kubernetes and containers are new to a lot of people. So it's like, I'm trying to figure it out. Where am I vulnerable? How do I secure this? What are the best practices? So that's probably something I think that will go away with time, and knowledge and experience will help with that. The other interesting thing we saw was kind of data management. So, there's a lot more stateful apps, being run in containers using persistent storage, a lot more data being generated and accessed by containers. So, a data management, I don't think that's necessarily unique to containers, but, we know that data has been growing tremendously over time. And so now that problem is, well, how do you address this problem in the container?
I think a lot of this is being driven from customers taking that technical debt footprint and lifting and shifting it in its current capacity to migrate it. And then later, when they start evolving that lift and shifted workload, they then start to address a lot of these concerns, or get themselves into an architecture that works in an easier fashion. And I think what they're doing is they're taking some of the challenges of that legacy technical debt footprint in their first phase, and they're persisting that, and they're going to address that later, because what's more important to them is potentially getting into a cloud environment like AWS. And that's not in necessarily every single customer, but I do see a pattern of that. Customers having a priority of getting into the cloud, and they pick things up and get them onto the cloud, and then they start to evolve them to the next step. Armando, are you seeing something similar on your side? I think that we're going to touch on this to some degree in your discussion as well.
Yeah, thank you, Ryan. And absolutely, I want you to keep in mind the top drivers and the top challenges. And when we get into the discussion about the operational value that OpenShift brings, specifically around the AWS side, we will see that OpenShift tries to answer all of these drivers and these challenges with the many benefits and the tools that it brings. So definitely, we see a lot of this with our clients and our customers.
Yeah, one of the things which is kind of just below the top four here is kind of skills, and that's something that I've heard a lot from customers, that they just there's a very small limited number of Kubernetes experts that are out there. There's not enough to go around. Maybe that problem will get better over time, but it takes a while to build up that base. But right now it's very difficult to find. So often people are having to do more with less. I think it has big implications for cloud and managed services as well, to help alleviate some of that. Next slide. So this slide shows kind of where enterprise containers are deployed. So this looks at the dark blue at the bottom is public cloud, and the top two are on-prem, kind of split between this idea of a private cloud or more traditional IT, whether it's bare metal or traditional kind of server farm. But if you look at the kind of the split between public cloud and on-prem, it's very interesting, because it was fairly equal before 2020, and then 2020 there was a pretty big jump to public cloud, and that was really because of the pandemic. And that's something that, as you can see in the later years, that we don't really see kind of changing, right? That's sort of a permanent effect. And a lot of that, obviously, I think containers have always had this affinity with cloud native, but with the pandemic, that really sped it up, right? Because people all of a sudden had to react very fast to different situations, for whether it's work at home, different business model. They started using more managed services, because the speed that they needed to get things up and running, that was like the fastest way, and maybe they didn't have the right people, they could hire them in that moment. So it's a pretty big change, and it's a pretty permanent change, right? Because mostly where workloads are deployed, that's kind of where they live until they die, right? I mean, there is some migration and stuff like that, but it's largely permanent.
I'm seeing distinct drivers with the customers that I've interacted with over the last 2 years. It's increased agility, increased resilience, increased elasticity, and customers are getting that more from their cloud providers than they are from getting that from their own data centers. They're just able to do a lot more quicker. And I think the pandemic, or 2020, really highlighted that for customers. It aggravated it for some, and it became a very clear indicator what you're trying to work towards is the right thing to do, and you now need to actually accelerate doing it. And I think some of the customers had already taken those steps, were really good advertisements for this is where the success is, and now we're seeing a tremendous customer base following suit. The other aspect of it is, with many industries sort of shutting down through that 2020 space, costs have become a even greater focus point. Many of the customers I work with lost revenue in that space, and are now trying to recoup that as well as grow their businesses. And cost leanness, when you're managing your own data centers, your own infrastructure, a lot of customers are now looking for, as you said, a managed service, and they're looking for something where they pay for specifically what they're consuming. They don't want to go into an OpEx sort of model. And I think we're going to see that persisting. Again, I think these numbers are somewhat conservative. I think we're going to see a snowballing effect over the next 5 to 10 years.
Yeah, and if I can add there, one of the things that we saw a lot in 2020 is our customers wanted the ability to scale to meet demand. And when we saw the transition to customers utilizing smart apps, shopping from home, it's a little bit difficult to implement that quickly inside an internal data center, but definitely the advantages that the cloud offers is able to meet that increased demand. And that's one of the main drivers that we saw for adopting cloud technologies.
Just to be clear, we're not saying that customers can't scale. They absolutely can, but they can only scale within the confines of their current investment. And then they get into a procurement cycle, and that's where most customers' wheels fall off. It's that procurement cycle is too long, and that's where the cloud really steps in and allows them to scale beyond that.
Next slide, Amanda. And on this side, we take a deeper look into how people are using container services in the public cloud. So the top two are fully managed services, right? Either from a native service or from a third party, but someone manages the service. And the bottom two are really self-managed. So you're getting the software, you're just installing it in the public cloud. So it's almost 60% of customers that are preferring managed models. And I think this is changing year over year more and more in terms of managed. I think in the earlier days of containers, some of those services weren't available in the cloud, or they were kind of in early versions. So people kind of did it themselves. But as those offerings have matured, we're seeing a big shift towards managed. Which I think is really the value prop of public cloud, right? Not to use it as just commodity infrastructure, but
well, not just the cloud providers. Coming back to your earlier slide, we're definitely seeing a skill set requirement, and customers. There are some customers who don't have the skill set to do this in-house, and they want a managed offering to offset their lack of skills or their lack of resources. And managed offerings from AWS have been, really, really attractive for several years now. If you look at Red Hat OpenShift, for example, there's a growing portfolio of managed services there, and customers have been saying, I want to manage my cloud through a managed process, but now I want that from OpenShift as well. So we're seeing that growing managed portfolio. To contrast that, we're not just seeing this for customers who have a skill set or a resource challenge. There are customers who have a very strong skill set and have resources, but would prefer to focus them somewhere else. And again, that is driving, why must I use my resources to keep the lights on when I can have somebody else manage it for me? I'd rather have my resources focused on something more strategic to my business. So I think those two dynamics are equally growing this shift to managed. And I don't think that's going to go away. I think that is very much the new norm for customers. Is if there is something that I can take advantage of to manage things for me, I'm going to utilize that.
Yeah, I totally agree. I mean, I think a lot of customers, right, like managing a Kubernetes cluster is not really strategic for them. It's kind of a low value activity. Next slide. So if you look at the applications that are deployed inside of a container, right? So what we see is in the enterprise, there's a very even mix of existing apps, that were running on bare metal or a VM that were moved to a container, sometimes refactored, sometimes not, and then new applications which were kind of born in the container. A lot of them are microservices. So in the enterprise, it is a very much of a mix of those, which is expected, right? They have a lot of legacy. But the thing is, I think a lot of people maybe only think of containers. It's only for a microservices cloud native application, and it's not the case. People are taking existing applications, moving them, doing some kind of various refactoring, and even new applications that we find, they're not always built from day one as a microservice. A lot of people experiment as a monolith because it's faster. And then once they start scaling and you get more demand, then they can figure out how do they rebuild that as a microservices, where the service boundaries are. So it's a much more complicated scenario in terms of looking at new and existing and microservices or not. But there are benefits, for customers for all these things. Obviously, I think you'll get the most benefit if you are very modern and refactored. But there are benefits, even if you're running, a monolith. So, people
I
still
think
get
the nuance here is what is important to the customer. Is the primary goal here to get to where they want to be? Is this a cloud migration and they want to use the container for its portability capabilities? Then that monolithic lift and shift comes into picture. If it's really to refactor an application, to evolve that application, because that's the most important driver, then we tend to see a recreation of that application, and then it's a new app. What for me is interesting is we're now starting to see a very dense interaction with ISVs or software vendors that historically would provide software to like financial institutions, telcos, oil and gas industry, taking their existing offerings and containerizing those and giving customers now choice of portability, running these things on top of container platforms like OpenShift, for example. IBM, I think, is one of the most notable ones at the moment doing that, taking their entire portfolio and repackaging it for customers.
Yeah, and there's a lot of value for customers because for those complex applications, you have things like Helm charts and operators, which wrap a lot more of the deployment mechanics and day-to-day operations and ongoing operations, which there was never really that much of a standard with VMs on how to do that. So yeah, I think it's easier there's a lot of benefits to ISV and the customers, but then a lot of those are also being remotely managed as well.
Mm.
Next slide. And this slide is kind of looking more deeper into the existing applications. So this looks at, of all your applications, how much code change did you have to make to containerize that application? I mean, and just to get it to initially run in the container, whether you refactor that further later or not. So, almost 80% of the applications are like kind of little to medium, and about a quarter of the applications are significant changes. And on the flip side, on the chart on the right, we look at migration time. So like, all the existing apps that you move to a container, how long did it take you, right? So it's, around 60, about 2/3, like less than 3 months. And then the rest, are larger, more complex applications that, took 3, 6 months, sometimes, I've known customers that take a year. And so that migration time is, often I think mixed in with, we're moving to a container, but we're also refactoring as we do that and moving it to the public cloud, as we do that. So it is really kind of, it could be many changes, not just like, just sticking the thing into a container.
And I think when we get to Armando's sort of discussion a little bit later on, I think we're going to get a slightly different perspective of this exact slide.
Next slide. And then the next slide really looks at kind of migration, the refactoring. So a lot of people will, I guess there's kind of two camps. Some people refactor it as they migrate it, and then some people like, let's just get it up and running in container, and then we have this long, many phase kind of journey to refactor this thing. So we found almost about half of apps are going to be refactored, over time. And we find that, I think users are getting more realistic about what can be refactored into what level. I think most people had more overly optimistic things at the beginning, and then they get more experience, and then they really figure out, well, it's so much work to refactor. At some point, it's just easier just to rebuild the whole thing from scratch. So
there's a risk profile here. If you look at customers in certain industries where those applications are so critical to be in a running state, they tend to live and breathe and die in their current form, while that customer looks at building a complete new replacement for it. And depending on the risk profile, the customer may make that decision to not refactor it, not because they can't, not because of the right thing to do. It's just because of the risk associated with that application needing to be in a persistently running state. Again, I think this is a very nuanced slide. I think for the customers I interact with, there are different workloads where the question around, do I refactor it now or later, or do I completely leave it in its current state and replace it at a later stage, is very much driven by the nature of that application and how it intersects with customers consuming it.
Yeah,
Yeah.
and even I found that refactoring is not like, hey, we're going to refactor everything. There's a lot of kind of this
Little
monolithic core that people don't want to touch, and it doesn't really need to change that much, but people will put some of the faster changing parts around it. They'll refactor that, right? So yeah, very very nuanced, very very workload dependent.
And I think that this is where the hybrid environments really play a key role, where some of the customers that we're seeing want to refactor and move and migrate, but also have to leave part of their mission critical pieces on premise, and they need to ensure that they can create that secure, scalable hybrid environment so that the whole application can coexist together happily.
And data is a big portion of that. Like, especially if I'm an enterprise with decades worth of data, it doesn't always make sense to move my entire data payload. Some of it will obviously transition into the cloud, but in many cases, customers prefer to almost start fresh with their data payload and aggregate it through another means.
Next slide, Amano. So now we're going to talk about specifically about the OpenShift and AWS business value study. So we basically interviewed 8 customers that are using OpenShift on AWS in production, and with a minimum of 6 months of experience. And so this paper, the full paper, will be made available after this event, and so you can read the full breakdown of all the numbers and charts and all of that. We're just going to go over some of the highlights here. Next slide. So overall, the average annual benefits per organization we found was almost $11 million, and that's broken down into 4 main categories. So one is business productivity. So this is higher revenue from more functional and timely apps and services, higher employee productivity. And the second largest area was around IT staff productivity. So that's basically more efficient operations and management, and more productive developers. And then the third area was risk mitigation. So that's basically less downtime, and avoiding kind of lost revenue from not being able to transact business. And then the fourth and the smallest area was the IT infrastructure cost reduction. So that's really the cost of the platform, the software, and the infrastructure, the avoidance of on-prem costs by using cloud, and the benefits of moving to a pay-as-you-go kind of consumption-based model. Next slide. And so this slide shows kind of before and after OpenShift on AWS in terms of developers getting access to compute and storage. So this basically reduced provisioning times anywhere from 64 to 74%. And this really kind of removes infrastructure as a blocker to productivity, where they don't have to waste time waiting on infrastructure. And this is kind of enabled by a lot of different things. The automated self-service process, having the infrastructure kind of be infrastructure as code in a modern API-driven way. So, I think there's really 2 parts of this that made this happen. There's the underlying cloud infrastructure layer from AWS, right? That can give you kind of really fast access to that compute and storage. And then OpenShift taking that and making that developer friendly, right? Presenting that to you as a Kubernetes cluster and containers.
And you're seeing this get even faster because of the closer and closer integrations with things like OpenShift and AWS. And if you look at, for example, operators that now manage storage for an application team in OpenShift, in the past you had to go into AWS, provision the storage, bring it into your cluster, and then present it back to your applications. You can now do all of that from within OpenShift and have it dynamically done for you. So the operational aspect is becoming faster and faster, and it's now complementing the developer agility as well.
Yep. Next slide. And so these were the benefits of the improvements to developer productivity. So 24% higher productivity. And a lot of this is the reason why containers became really popular, right? It's very developer friendly. It was the workflow is kind of geared towards making developer lives easier. And so people have basically faster software development life cycles to these modern tools and workflow. It's easier to ship code. and is really made, to support, cloud native microservices development. And so this basically lets, the goal, I think, of most kind of, platform as a service, whatever you want to call it, in cloud services, is to let developers focus more on code, make infrastructure, kind of less of an obstacle. And the other part of this, which I think is interesting because of this is just OpenShift on AWS, is that they get the fast access to AWS services, right? So that can help accelerate development, right? Because you can get a lot of managed services, whether you want AI or, as a service, you want a managed database or blockchain, right? All of these things are really being made, that developers can just integrate into the app, and so they don't have to spend a lot of time managing those things.
Absolutely.
Excellent. And this is really looking at the shift in savings, where people were able to take the savings that they saved on the platform and invest more in developer staff. So we found basically people were able to save about a third of the cost in the platform, and that ended up being about 10% of the overall budget, and put that into a developer. So as we know in digital transformation, a lot of it is really around transforming software, right? Deploying software faster, reacting, innovating. And so, basically, developing that code and creating valuable IP is the stuff where you really want to focus your time, and not on managing infrastructure. So, with those savings, we found that people basically were, either hiring new talent, bringing new people that had, container, cloud native, microservices skills, or putting that into training, training people on containers or Kubernetes or new software development methods.
And I think one of the things to highlight here is that being able to save and being able to bring in new developers really accelerates that development process. It means that organizations are able to create feature development and new products out to their customers at a lot quicker pace, right? The velocity increases as well as the cost savings.
Exactly. Right, next slide. So this is looking at kind of the 5-year infrastructure costs of moving to OpenShift on AWS on average. So the cost savings across the core infrastructure and the platform, the IT staff efficiencies, and the cost of the downtime. So basically, I think the infrastructure cost, we're moving to a pay-as-you-go consumption-based model. It's much easier to match, what the capacity you need and what you are actually using, right? So you avoid this whole kind of, I think Ryan was mentioning earlier, this whole underbuilding or overbuilding, right? Trying to predict that, which can be more and more difficult as, all this digital transformation goes around. It's very hard sometimes to predict, what's going to happen, what's going to be a success, what's going to need, massive scale very, very soon. And then, of course, management efficiencies that we see with infrastructure as code. You're spending a lot less time just keeping that core infrastructure, up and running. And then we saw a huge improvement in less downtime with OpenShift on AWS. So, Kubernetes is part of that. It has a lot of things that can, keep apps running better. But a lot of that is also the cloud infrastructure underneath, right? I mean, obviously AWS, massive cloud, global presence. And just keeping that, that core physical and virtual infrastructure underneath Kubernetes up and running is important too, because Kubernetes runs on real infrastructure.
We saw this play out in a very real sense during 2020, where you had one customer shutting down and needing to basically scale down to the smallest footprint they possibly can. And on the opposite side, you saw a different customer, and these are typically people in a retail space, having to frantically scale up to significantly larger than their business had in the past. And really the benefit here isn't just the cloud. It's not just AWS. It is something like a well-formed modernization practice, something like OpenShift sitting on top of AWS, balancing your application workloads and helping your developers as they sort of fit into that infrastructure context. I think the complementary dynamics of something like OpenShift and AWS are really attractive to customers.
Next slide. So this is kind of the overall summary. Some of the highlights that I found, I think most compelling was we found basically a 661% 5-year ROI with 5 months to payback. And as Armando was mentioning, the software velocity. So the customers were able to get out twice the number of new applications, which means I could get to market faster, they could innovate with new products or expand in new markets. And that totaled almost $33 million per year benefit. And I think overall, customers really mentioned that they liked OpenShift as this kind of enterprise-ready, turnkey, complete container platform, all right, from a trusted open source vendor in Red Hat that paired really, really well with the super reliable, scalable, on-demand infrastructure from AWS, as well as all the other AWS cloud services that they will get access to by running on AWS. All right, thanks. I think I'll turn over to Armando for his comment on the TEKsystems, and I'll be here at the end for Q&A.
Thanks, Kerry. And thanks again, everybody, for joining us. What we're going to talk about now is the operational value that Red Hat OpenShift brings to organizations, how it's able to achieve all those impressive numbers that we talked about earlier. One of the things I want to keep your mind on is the challenges and the drivers for the customer's case for moving towards the cloud managed services in OpenShift. Operational value from OpenShift is really divided into 4 pillars or 4 key areas. One of them being the container management strategy, a holistic approach on how OpenShift looks at the development process. We also, the integrated cluster services, the operators and the operator framework that Kubernetes offers. OpenShift has taken that one level higher and really integrated the whole platform with it. Also, OpenShift is perfect for the hybrid environments and the managed services. Now, Red Hat and AWS have partnered together to create a very easy to consume managed service for OpenShift that empowers development teams and operational teams alike. And finally, we talked a lot about the data. How are stateful applications going to be able to run efficiently on a container-based platform, especially when you could have clusters spread out throughout the world in private data centers, but also on AWS, right? So OpenShift has created this product called Data Foundation. So it really highlights and really brings that power of being able to spread data out through your clusters and provide that persistent storage.
And that directly integrates with AWS's storage options. So you're really getting the best of AWS's storage portfolio combined with something that is really complementing OpenShift through that ODF platform. It's again the best of both worlds.
That's right. So let's take a look at the actual container management platform and how a holistic approach is taken and why it's taken that way. Now, we talked about a little bit earlier about that developer experience, right? Why it's important. Well, OpenShift is definitely platform and cloud agnostic, right? It lets it's common user interface that lets developers interact with it in the same way, in the same fashion, regardless of where the hosting platform is. Now, between AWS and your private data centers, developers are able to work on their applications and easily transition between the environments. But not only that, it also provides full stack hosting, meaning that regardless of where the platform is hosted, the platform can host all types of use cases according to your business and is you can customize it, highly customizable for AI, ML use cases, serverless use cases, edge computing, web applications. Now we're seeing a lot more of these businesses that require 1, 2, or 3 even of these use cases, and OpenShift has the power to and the ability to customize their clusters for it and allow developers to seamlessly move between the environments and their applications. Another really good example of how the container platform really offers a holistic approach is that it brings a lot of monitoring, different tools to allow companies to monitor all aspects of the development platform as well as the platform itself. You can monitor your applications during build, deploy, and at runtime, as well as the performance of the applications, while also maintaining that performance of the infrastructure. Companies are able to quickly identify their what KPIs are important to them and improve upon them. And all of that basically leads to what we talked about earlier, which is accelerated development. You want your bug fixes to reach production quickly, and through the use of OpenShift operators and Kubernetes operators, OpenShift really increases the velocity, increasing that mean time to release and enabling organizations to develop more and faster. And our last chevron here really talks about operational excellence. You have this fantastic platform that is also highly available and reliable, that has a cohesive central management. That central management piece really allows the management of a complex environment to be simplified. And as well, remember the key driver and the key challenge, security. This platform comes with integrated security for the platform and the applications, really helping round out the container management platform here.
I think there are two very critical call outs here. The first is, you can build everything here using, say, open source sort of tools, projects, or you could take a collection of cloud provider products and click them together. They've a lot of little building blocks. Customers don't necessarily want that. There's a large customer base that's looking for, I want to purchase a turnkey solution that gives me everything out of one box, and they're getting that from OpenShift, whether it's build, deploy, container orchestration, monitoring, everything's already there. They don't have to solve how to integrate things. And the other aspect, and you can see it very clearly in that first column, is everything that you get here doesn't interfere with the developer process, whether I'm running on premises, on the cloud, if I'm in a hybrid context, whether I'm self-managing OpenShift, whether it's managed for me, the developer experience is consistent across all of those use cases. So my developer gets to put their head down and build applications that are important to my customers, and I don't have to worry about a technology ramp up or a process change or an interface change. Life just carries on for my developers. Yes, there may be some nuance for operational infrastructure teams, but that's where AWS and Red Hat come together to try and simplify that as much as possible.
That's right. Thanks, Ryan. And now we can talk a little bit about the how all of that is enabled. In order to enable the developer to work seamlessly, regardless of where it's at, and how to increase velocity, OpenShift has really taken advantage of the operator framework that is available for Kubernetes. The OpenShift ecosystem has integrated operators very tightly into the platform. Basically, an operator is a piece of software that eases the operational complexity of running the container platform. But what does that mean exactly? Is that through the use of operators, administrators are able to upgrade the core OS, scale the cluster easily, consistently, and automatically, but also the applications and the services running within the OpenShift ecosystem, the install, the update, the maintainability of those applications is now automated through the use of operators. And operators, basically, operators are offered in many different types of use cases, right? We have operators that enable your continuous delivery and deployment pipelines, operators that enable security and compliance, continuous resiliency, data analytics, messaging, caching. It really make the platform customizable and make it easier to utilize. Operators really enable the underlying Kubernetes engines to streamline and automate most parts of the Kubernetes platform, therefore leading to less operational and maintenance time spent on the platform and creating cost savings for the organization.
We've noted significantly decreased time to installation. So the entire installer process has been made so much faster by this. Less downtime, less patch management issues. If we look at the integrations with AWS around storage and compute, the ability to control your AWS compute layer with things like machine sets, machine pools, now machine autoscalers underpinned by operators. There's an operator for EBS storage. There's one for S3. There's integrations coming with the Amazon controller for Kubernetes, and it's also going to be wrapped around in an operator in the near future. Everything is touching operators, even our ISV software components that stack on top of OpenShift. You look at something like your security and monitoring layers, things like Dynatrace, Splunk, Aquasec, Quay, all of those components now being operators that a customer can very, very simply deploy and integrate with their OpenShift workloads.
Yeah, Ryan, I also want to point out that there's some complex frameworks that need to be layered up on top of Kubernetes when running Kubernetes, for example, like Istio, right? Well, Istio comes as an operator already available to OpenShift, along with many other operators in the Operator Hub for very popular pieces of software that allow the development process to really be sped up. Your CI/CD processes can be enabled very quickly, allowing you to set up the delivery pipelines that get your applications to production in a faster manner. Now, the next piece that we want to highlight or touch is the ability for OpenShift to really shine in a hybrid environment, as well as utilizing managed cluster solutions, right? When organizations are looking to establish their strategy for modernizing into microservices, there are big questions to answer, right? The questions are, can we maintain stability, reliability, security, compliance, governance across the complete hybrid environment? Thankfully, Red Hat and OpenShift have the answers for that, and they've been really working towards enabling organizations to make this simpler. The first piece is the advanced cluster management that OpenShift brings with it. It really gives administrators a one pane of glass to be able to manage their Kubernetes clusters regardless of where they're hosted and regardless of the number of them. Imagine being able to provision, to update, to maintain all the clusters from one screen, from one window. And not only that, another benefit is you're able to set up centralized security policies so that when clusters are being spun up, clusters are being utilized, they are using approved security policies set by your IT security teams. That really helps bring down the management costs, but also ensure security, governance, and compliance is followed. Another aspect, while we're talking about security, is the advanced cluster security. Now, this add-on to OpenShift, it really integrates well with the OpenShift ecosystem in that it can scan our infrastructure for vulnerabilities and maintain CIS benchmarks for best practices, but also integrates with the development process into the CI/CD pipelines. So advanced cluster security actually builds guardrails for developers to follow, and it also scans container repositories to ensure no vulnerabilities make it into your developer release stream. Between the cluster management, go ahead.
Very quickly, coming back to Gary's, I think, very first slide, where customers are looking for security, but they're not quite sure how to approach it, that difficulty of security. This really provides a guided, prescriptive approach to security. A customer doesn't have to solve everything themselves. They're getting that from Red Hat. They're getting that from AWS. There is that guided approach. And this is why so many customers are gravitating towards something like an OpenShift platform.
Yeah, absolutely. And I think, to add on to that is the managed service offerings that Red Hat and AWS have now partnered up in creating. We have the Red Hat Openshift Service on AWS, or better known as ROSA, that really lets teams spin up OpenShift clusters without worrying about the underlying infrastructure and just getting to work, putting the developers to work, building out their applications. You can integrate the ROSA offering into CI/CD pipelines. Operational teams can utilize ROSA to ensure business continuity. we can maintain, we can spin up a ROSA cluster very quickly with a few commands on the AWS CLI. And one of the operational advantages is that it's included into your one AWS bill. It's all consolidated together, and you get the performance of OpenShift as well as the reliability of Red Hat in AWS in that offering. And the last piece we're going to take a look at here is really the multi-cluster storage. And for that, I'm going to move to the next slide because we felt that one slide dedicated to storage was warranted here. Red Hat OpenShift Data Foundations really is the new offering from Red Hat that wants to really marry all the benefits of the cloud, of on-premise, from OpenShift managed services all into one easy to use cohesive package. Data Foundations really provides the storage solution to address all the complex use cases and simplifies the overall solution. It kind of creates a managed service offering within OpenShift for data. It allows developers to provision their own storage, regardless of where that storage is, whether it's the cloud, whether it's on-premise, whether it's legacy, whether it's file, data, object storage. No longer is the need for a ticket warranted. You don't have to spend hours or days waiting for that storage to be provisioned for you. OpenShift Data Foundations can actually provision it for you. And not only that, but the management of the Data Foundations is run through OpenShift itself, through again through the operator framework. Operators really enable OpenShift to shine. Another advantage to Data Foundation is the fact that it's workload agnostic. You can provision specific storage for SQL, NoSQL, for data at rest on databases and warehouses, for data in motion, such as data pipelines, and data in action, which analytics, AI, and ML is a huge it's a huge driver, right? As we saw at the very beginning, AI and ML is one of the reasons why customers are looking to the cloud, and specifically OpenShift here.
Well, what I like about ODF specifically is you're taking the cloud provider, or the environment-specific storage mechanisms to their full capability. You're getting everything from EBS, you're getting everything from Amazon S3, you're getting everything from EFS, and what you're doing is you are representing that through ODF, and you're abstracting away any sort of unfamiliarity or complexity. So a developer doesn't need to know the specific storage capabilities of the environment they're on. They're just going into ODF and they're able to use it through ODF, but still get the full benefit of the underlying environment, AWS as an example. And this is where we're seeing that very tight partner relationship. As we change things, as we bring new products and services from AWS, we're bringing those into Red Hat's ODF platform. And as they're bringing new features such as their replication, this product is going to evolve to become a much larger element of every customer's environment, especially if you're looking in a multi-region hybrid context. How do I replicate data from here to a different AWS region for DR capabilities? It's going to be through something like an ODF sitting on top of AWS resources in the future.
Yeah, thank you, Ryan. And I think, as customers are looking for that modern container hosting strategy, they really look at the management of the solution, the integrations with supporting software, and the storage options, the integrations with storage options, security of the platform, security of the workloads, and that the AWS integrations as well as the on-premise integrations. I think that Red Hat OpenShift Container Platform really brings it all together and offers that one holistic platform to be able to solve business needs of tomorrow. Now I want to really quickly talk about some real world wins and real world use cases that we've seen over the past couple of years. I want to be conscious of time and leave some time for Q&A, so I'll quickly go through this. And one of the things that I really want to highlight here on our first case study here from Best Western Hotels is that Best Western came up to came to TEKsystems with the problem statement that they wanted to provide a more innovative and engaging experience across their digital platforms. They wanted to redefine application development, and they wanted to respond quickly to changing customer market conditions and more quickly to delivering relevant application enhancements, right? So that definitely ties in and looks a lot like that very first slide that Gary presented. And what are the reasons why companies are looking to modernize a platform and adopt cloud adoption, right? The solution, of course, remodernizing the platform and the processes, new feature development, testing, production support for the critical applications. But the most important part here is by adopting AWS and by modernizing the platform, we were able to reduce the time spent fixing and maintaining applications and more time spent developing by 20%. Now that's a huge gain because now Best Western was able to respond quickly to their customers, and not only that, but provide a more modern experience for their customers. And the second use case that I wanted to just highlight here is one of the use cases that we are talking about, and is that data analytics and large data processing, right? In order to fuel agility and exponential growth, Lumentum needed unprecedented transparency into their manufacturing data. They wanted a holistic real-time view of that data and to be able to act upon it. But the problem here is, how do you bring data in real time from all over their manufacturing plants, right? Basically, TEKsystems then created a hub and spoke architecture with AWS at the core. We created edge devices to be able to collect that data and transfer it in real time to be processed inside of AWS, and then build the data analytics and build the data warehousing, AI, ML capabilities on top of that. The only way to do that and to be able to scale it is to be able to utilize a new platform and to utilize the power of AWS and the cloud. So, I just want to thank everybody for joining us, and I know we're short on time, but Ryan and Gary, now would be a good time to turn it over to a little bit of Q&A.
Yeah, so you do have a Q&A or a sort of control on your right-hand side of your screen. You can pop some questions in there. I think anything's on the table. You've got a fairly broad perspective of people that can answer. So let's see what questions come in. Question from Michael, which job functions inside an org typically see the most value in moving to a container platform, and more specifically managed by something like ROSA? That's a very interesting question. It's got a couple of dynamics to it. From my side, I don't see it as something related to a job function. The customers that have really made a success of this, that modernization change, that organizational change isn't specific to job functions. It is across the entire organization. And you're starting to see, it started with developers getting that benefit, but now, as if you look at Armando and my conversation, a lot of it is moving into how do operational and infrastructure teams get benefit from that change as well. We're seeing security teams become a lot more agile, and we're seeing the rise of DevSecOps coming in. It's even bleeding over into other parts of the business, such as, if I'm creating new applications and I'm able to deliver those to my customers, how does that change my go-to-market and my marketing and my sort of sales processes as well? So all aspects of the business, independent of role, are going through a state of reinvention for a customer as they modernize not just their applications, but their business as well. Where ROSA comes into the picture, really there is an audience here, and I think the biggest stakeholder is going to be infrastructure teams, administrative teams that were responsible for implementing OpenShift clusters, standing them up, maintaining them, keeping the lights on in support of developers. a lot of that goes away because now you've got somebody like a Red Hat SRE team managing that platform for you, and it frees up those administrative or those operational heads to focus on other elements of the business. During 2020, a lot of that administrative shift moved towards how do I support my workload, my workers now being remote workers, and I needed somebody else to keep the lights on while I strategically refocus there. Armando, I don't know if you're seeing a slightly different perspective in that regard.
No, we're actually seeing the same thing, especially when it comes to Rosa. Rosa is really freeing up the ability of operations teams to focus on different areas, right? Specifically tackling any technical debt that organizations, especially enterprise organizations, tend to acquire over the years, right? Once we can free up our engineers from having to worry about keeping the lights on, we can start really focusing on on the development process and really developing customer wants and needs, and really reacting it to the job, to what customers are asking for. So really what we're seeing is that accelerated development is happening due to offerings like Rosa up on AWS.
And to be clear, that's not a benefit of ROSA per se. That's really a benefit of managed services in a more general sense, whether that's something like relational database service, RDS on AWS, or whether it's ROSA, you're getting much the same thing. Another area where ROSA does become a very compelling item to customers is it's a new billing model. It's a new procurement process. So how you purchase it is different from traditional OpenShift. It's a faster process. You're going directly to the AWS console, you click on a button to enable it, and then you're up and launching your cluster. You're not having to deal with, do I have the correct subscriptions? Do I have to manage my subscriptions? It's a pay-as-you-use service. You use it, you pay for it. The minute you stop that cluster, there's no longer a cost incurred. And that's not a benefit to a specific hat in the organization, but the organization holistically from a cost perspective and an agility point of view, and being able to get developers working with it faster, that is where we're seeing the greatest significance. How are we doing for time? Do we have a time for another question?
I think we're at time, but if there's another question out there.
Question coming in around customers who are already on OpenShift, and what does that transition look like from an existing self-managed OpenShift to a managed one? And I think that's an interesting thing. I think the big call out there initially is there is no change to the developer. The developer process is exactly the same whether you are on self-managed or managed OpenShift. For operational infrastructure teams, yes, there is a benefit, there is a change because somebody else is managing it for you. There is, to some degree, a migration process. So, you are sitting with a self-managed OpenShift cluster, and now you've got a managed solution in the form of ROSA. How do you transition those workloads across? And I've seen customers do a couple of different strategies around this, whether they're using their CI/CD pipeline automation process to redeploy things to the new cluster. And I'm also starting to see a very large uptick in customers using things like the Red Hat toolkit for container migration. So where they have a toolkit that installs onto ROSA and a toolkit that installs onto their self-managed cluster, and it's able to back up and transition all of those components across. There's a couple of blog artifacts and things coming out both on the AWS and Red Hat side, so look out for those artifacts with regard to migrating from managed or self-managed OpenShift to a managed OpenShift. And I believe that might be all we have time for, unless there's something. Armando, anything else coming up on your end?
No, nothing coming up here. Just want to thank Ryan and Gary for having this wonderful conversation with me, and thanks everybody for joining us today. Really appreciate it.
Yeah, as always, it's fantastic working with you.